out at the beginning of the lesson, definite integration. So this is what definite integration is. See if you can see the difference between this and what we were doing last lesson. Welcome back. Hopefully you realise that we have a boundary which is defined. So this means we are given a number at the bottom of the symbol and at the top of the symbol, which means we're going to integrate between two values, or we're going to find the area of the curve under two values. So let's look at a specific example. Evaluate x squared integrated between 1 and 3. So as before, what we're going to do is we're going to find the integration button on the calculator. So we're going to make sure, to begin with, that our mode is in Maths Print. Then we're going to press Quit. Then we're going to press Math. And we're going to go to Integration. Here we can put in the numbers. 3, 1. Then we type in x squared. You can see that this button only works for integration where it's definite. This means it's between two different numbers. Then we're going to have integrate with respect to x, and it's important to include this here. And then we just press enter. And then our answer is going to be 8.6 recurring. Let's check on the slideshow if this is correct. There we go. 8 2/3, or 8.666. Now, if you were to do this manually, all you need to do is substitute 3 into the integrated expression and then minus the substitution of 1 into the expression as well. Let's go over the next topic. The next topic could be for particular values. So we're going to talk about substitution this time. And let's have a look at this specific question. Find f of x given that f dash of x and f of 0 equals 2. So the first thing we need to do, like last lesson, is integrate it. This is because we're given the differentiated form. So to get to the integrated form, we need to integrate the differentiated form. So this is going to give us x to the power of 4 over 4 minus 2x to the power of 3 over 3 plus 3x plus c. So this is what you should have got, like this. Now, what we're saying is now we've got f of x, we need to substitute in 0 and 2 into this equation because we want to find out what c is. And in order to find out what c is, we need to put 0 where this x is, and then the whole answer is going to equal 2. So the best and easiest way to do this is to use your calculator and use the y equals button. So what I would do for this is type in x to the power of 4. But remember, we don't want to do x to the power of 4 because we want to find out c, and we already know what x is. X is 0. And in fact, if we substitute 0, 0 and 0, we're just left with c is equal to 2. So all we need to do is substitute 2 in for that. So that is particularly easy. Let's have a look at a little bit more of a difficult question. If a curve has a gradient function dy by dx equals x squared minus 2x squared and passes through 2, 4, find the equation of the curve. So because we've been given the differential form, in order to get what y is equal to, we have to integrate the differentiated form. So we're going to integrate x minus 2x squared, and remember, we must always include dx, which means with respect to x. So we're going to have x squared, increasing it by 1, and then putting the power below as a denominator. Then we're going to increase the power of 2 by 1, and then we're going to put this power as the new denominator, and then we're going to add c. So this is our y equals, and we can always check our answer and see if we differentiate this answer, will we get back to the question? And indeed, we would. So what we're going to do now is substitute in 2, 4. Because the curve passes through 2, 4, and the curve itself has a gradient function. So it's talking about the y equals rather than the dy by dx, which is the gradient function of the curve. So let's substitute in 2, 4. This means that where we have a y, we put 4. Where we have an x, we have a 2. So 4 divided by 2 is 2, because that's 2 times 2 divided by 2. This is going to be 2 times 2 times 2, which is going to be 16 divided by 3, and then plus c. And then at this point you can algebraically solve it, or for most of you it would be probably better if you put it into the y equals. So on the y equals, we're going to do 2 minus 16 divided by 3 plus x, and then we're going to press table. And we're going to have a look at when this is equal to 4. You can see that it doesn't ever exactly equal 4. It's going up in ones on the right hand side, but it's equaling 4.6 recurring. So because this is going up in ones, and I'd actually like it to go up in thirds, because then it's going to hit every third. So it's going to be 0, 1/3, 2/3, 3/3. So in order to change how the table's going up in, we press second table set, and we're going to say that the table is going up in, this is what the triangle means, 1/3. Then we're going to press second table. Then this is much easier. We're going to see when we get 4 on the right hand side, which is the y, and then our answer is 7/3, or 7.3 recurring. If you find this too difficult, what you can also do is put equals 4, and then you can put a graph, and you can just see where they both cross. This one's quite easy, so you just press second, calc, intersect, which is 5. First curve selected, second curve selected with the enter, and then in the center selected. There we go. It intersects when y is 4 and x is 7.3 recurring. Last but not least, let's go over a final type of question. And the final type of question we're going to go over is similar to that style, but a little bit more challenging. So the curve y equals f of x passes through the point. So as you can see, actually it's the same as before. So the first thing you have to do is integrate this. So that's going to be the following: 2x to the power 4 minus 5x squared plus c. And because it goes through 2, 9, all we need to do is substitute. And I'm going to show you algebraically how to do it this time. So we just take the 9, we substitute it into the curve, and then we're going to substitute 2, and then we're going to just solve for c. And we say c is minus 3, and then we take our original function, which is here, and substitute in minus 3. So those are most of the topics we need for integration. I hope that made sense to you to some extent. If you'd